Okay, so this is your typical combustion problem, and it gives you that you have 3.489 grams of the a compound containing CH2, and when it combusts, so you know oxygen is involved, it yields 7.832 grams of carbon dioxide and 1.922 grams of H2O. So what we want to start off with is we already wrote out the formula, we're going to find percents. So, and percents that will lead to grams. So from this 7.832 grams of carbon and oxygen, we know that the molecular mass of carbon is 12, and the oxygen, there's 2 of those, and the molecular mass is 16, so that is 32 plus 12, which is 44. So the entire formula mass of carbon dioxide is 44. Equals formula mass. So now we want to find the percent of carbon and the percent of oxygen, then we're going to change it back to grams. So the percent of 12, which is carbon, so carbon is 12 over 44, which is 27.27%. And then oxygen will be 32 over 44. Is 72.72%. Okay, and we'll do the exact same thing with H2O. We know that H2O has a total formula mass of 18. 1 for each hydrogen is 16 for the oxygen. And so we know that 2 over 18 for the hydrogen is 11.11%. And for the oxygen, it's 16 over 18. We write an H up there so you can follow. 16 over 18 for the oxygen, which is 88.88%. And now we want to change all these percents into grams. So what we will do is, again, multiply the percent by the total. So we'll do 7.832 grams of the total CO2 times the percent of carbon, which is 27.27. So that gives us 2.136 grams of carbon. And we'll do the same thing for the oxygen. We'll multiply 72.2% times, 72.72% times 7.832 grams, and that gives us 5.695 grams for the carbon. Now we'll do the exact same on this side. Multiply 11.11% times 1.922, and so that will yield us 0.214 grams. And the oxygen is going to be 0.888, which is 88.88%, times your 1.922, which is 1.708 grams. I know this is kind of sideways. Hope you can read it. Okay, so now we have the grams of each of the products. So now we want to put this in our reactants. We know that all from the law of conservation of mass of matter, matter is neither created nor destroyed. So whatever we have on this side, we'll have on this side. So carbon on this side, out of the 3.849, we know that carbon will be equal to 2.136 grams of this. We know that the hydrogen will be equal to 0.214 grams. And we know that we have a total of 3.489 grams for all. So we're going to add these two numbers up and subtract them by 3 from 3.489 to get the grams of the oxygen in the substance. So we'll add 2.136 plus 0.214, which is 2.35. So we'll do 3.489 minus 2.35, and we'll get 1.139. However, you'll notice that there's obviously more than 1.139 grams of oxygen over here, and that remaining oxygen comes from here. So just for our purposes, we'll add up the total of these. We'll add up the total grams of oxygen, which is 1.708 plus 5.695, which is, so the total of oxygen is 7.403, and then we'll subtract from it the 1.139, which is the oxygen used over here. And 6.264 grams will be your answer for the total amount of grams of oxygen. So now the problem says that, hold on. Okay, so now the problem says it wants the simplest molecular and, okay, it says that what is the simplest formula for this compound. Okay, so now we have the total number of grams. We want to convert them to moles. So each of the formula for moles is moles equals grams over formula mass. So each of these numbers we're going to divide by the formula mass. So we'll divide carbon by 12, hydrogen by 1, and oxygen by 16. And here are our products. So we'll have 2.136 divided by 12 is 0.178. This is the moles of carbon. And then we're going to do 2.14 divided by 1, which will be itself, and 1.139 divided by 16, which is 0.071. And these are each of the moles, and we're going to do a molar ratio to simplify it down, so we'll always divide by the smallest, which will be oxygen. So we'll always divide by 0.071, 0.071, 0.071. So 0.178 divided by 0.071 is 2.507, and then our hydrogen is 3.01, and our oxygen is 1. And now we want to, since we can see that these are not whole numbers, we need to convert them to a ratio that will be whole numbers. And we'll always find a little bit of mathematical error, like with the 0.01 and then the extra 7 thousandths, but we could assume that this was meant to be 2.5, 3, and 1. So if we multiply everything by 2, we will end up with a C5H3O2. H6, I'm sorry. I'll make sure to multiply. C5H6O2, which will be your final answer. Thank you. Bye.